So, welcome to another episode of Beta Talk. This season is being sponsored by Primary Pro, and Primary Pro is a professional outside lagging system, pipe insulation system that a lot of my very good friends who are great engineers are using. So, look them up on the website. Today, I'm joined by Henry Pelly. Now, Henry is a principal sustainability consultant at Max Fordham, so we're going to be talking a little bit about the consultancy world. He's a qualified architect with a master's in environmental design in architecture. He's also got a master's in environmental psychology. He's also set up an MCS installation company, which has been doing air to air as well as air to water. He's a dad of three young girls, all under 5, so he's got his work cut out there. And he's also set up some wedding venue, and we're going to be talking about that because he's obviously comes from the architect world, so he might be making that quite a sustainable facility. He's rowed for the country, he's rowed for Great Britain. He's done lots of industry training, so we're going to be talking about training as well. And importantly, he's a very avid fan of the Beta Teach podcast. So, Henry, thank you for being a listener, and thank you for coming on the show. So, I mentioned that you're a consultant for Max Fordham. Max Fordham is obviously one of the most well-known sort of consultancies in this sector. We've got all sorts of different consultancies. There are different types of consultancies, and some of my listeners will know I've sort of pushed back against some of the work. I mean, we always hear this thing of a skills gap in the sort of in the installer sector, but there's definitely a skills gap amongst the consultancy industry. But there are different types of consultants. I mean, what are your thoughts around the consultancy industry at the moment? What's because obviously we're changing, we're transitioning. Has it affected your industry much?
Yeah, I mean, definitely things are being done differently. So Max Fordham are an environmental engineer, MEP consultancy. We also have an acoustics team, and quite a sort of large set of what we call specialist teams. So sustainability consultants, passive house consultants, people doing building performance modeling, and we also have a light and air team who do um, really kind of interesting building physics and kind of CFD modeling and that kind of thing. So understanding doing lots of really interesting work around understanding what's happening in buildings in terms of ventilation and flows and daylighting and lighting design. So we have sort of broad remit, but we come from a sort of MEP background, and traditionally that's where sustainability consultancy is also delivered. So you know, obviously we work with architects on projects to do the MEP design, and then I deliver some sort of other stuff around that. And I think um, certainly from Max Fordham perspective, uh, since 2017, we've been sort of really basically heat pumps, like decarbonized heating is absolutely the driver, and it's pretty rare to do anything that's kind of fossil based. But there's definitely a learning curve in terms of um, sort of everyone getting on board within the industry in terms of understanding what that means and how that might change the way these designs are done.
I mean, because obviously we're talking sort of commercial sector. So are you seeing a lot of that commercial sector just completely switching away from fossil fuel boilers?
Yeah, I mean, I wouldn't. I would say it's even. I mean, a project I remember working on a project about in 2021, and the client was finishing a building, not designed by us, but they were finishing a building, and it had gas boilers in it as for the space heating and hot water demand. And I was sort of surprised, and they were feeling like at the time, a few years before, it had seemed like a sensible, cost-effective thing to do, but right now, as they were trying to transition, they were then developing a plan to be net zero carbon, and they realized that pretty instantly they were going to have to come back to that scheme and look at how to remove the gas boilers that were like about to be commissioned, because if they wanted to be net zero carbon by 2030, that couldn't be on. But the thing is that it had changed so much over those 3 years between that decision being made and the building being completed. The idea that fossil systems were kind of unacceptable in buildings wasn't yet the the kind of the thinking in that world. I mean, when I started as a sustainability consultant in 2013, and Uh, I worked on a project kind of a year later. I worked on a development for a big arena listed building, and we did a low zero carbon technology report looking at all the different kinds of ways of decarbonising it. And the report in 2014, based on the UK grid at that time, and based on our assumptions about how quickly it would decarbonise, which was not very quickly, was that the carbon, you know, installing heat pumps instead of gas boilers for some many hundreds of thousands of pounds, maybe, not much shy of a million, of like several million, was going to save 4% in carbon terms, because the electricity grid in 2014 was, maybe half a kilogram of CO2 per meter squared, and gas, you know and then gas was, 200 and something, whatever it is, grams of CO2 per kilowatt hour output. So, like, sorry, get my units wrong, but basically the point was that in those days electricity was really dirty, and gas was comparatively a cleaner heating source in terms of the carbon emissions per kilowatt hour. So it was obvious that we shouldn't put heat pumps in, and that fabric first was a way to reduce emissions. And then that just changed, as the grid rapidly decarbonised from about that moment on, from 2014 onwards. There was a sort of plummet as renewables came online. And I think by 2016, it was really clear that the energy transition that we're being told was going to happen was definitely happening, and that any project that wasn't being electrified was going to miss out on the decarbonisation gains from heat pumps. So I think around that time, I have a very clear memory, 2016, 2017, loads of projects where we were like, heat pumps aren't necessarily an immediate carbon saving, but when they're by the time they're built, they're going to be quite significant. So at that time, I remember I had one of my favorite projects was, which is recently finished, or finished in the last couple of years, was the sports centre for University of Portsmouth.
Right.
And they had a target for a Dec A energy target. So they wanted to be in the top, I think it's the top quarter of sports centres of that kind. That was like an energy target. So they had BREEAM Outstanding, which is for sustainability rating, and Dec A. They want to be the first BREEAM Outstanding sports centre in the UK and achieve this Dec A energy rating. And the decision at the beginning was heat pumps. We're definitely going to do this thing with heat pumps. And I think it was quite innovative to do the whole sports centre with heat pumps, no gas backup, or combined heat and power or anything like that. And then, yeah, the project's been delivered. It is really low energy. It uses about 89 kilowatt hours per meter squared per year. So it's about a tenth of a typical sports centre.
What sort of heat pumps? Have you got a mix? I mean, is it air to air?
Yeah, no, so the kind of heat pumps in that. So, like, basically, you're doing kind of, I think it's four. My colleagues will probably call me out on this. I think it's a four pipe system. So basically, you are doing, the cooling. Obviously, in the summer, you are still heating a pool or getting close. You're often having to do quite a lot of hot water loads and doing cooling. And for quite a lot of the year, you've got a cooling load. So when you're doing the cooling in a sports centre, you can then be heating the water. So for a lot of the year, it's also naturally ventilated in lots of spaces. There's lots of kind of mid-summer, trying to get those, kind of like spring and autumn times, that it can be done, without active or minimizing the active systems. And everything's quite, in some way, things are comparatively oversized. So there's low pump, all the stuff you do to make a house good, in terms of, larger pipe runs, reducing the pump power that's needed. That stuff works on steroids in a swimming pool setup. So you oversize all the filters so that speeds can be lower, so that pump energy is less. And I think that project's great because at every stage, everybody got on board with pushing towards this kind of low energy target.
I
From the
imagine
designers, the
a lot of
contractors.
learning. I imagine a lot of learning went on to sort of get.
Yeah, so we had this series of things. So this performance gap. I'm getting off topic, but there was this historically the performance gap, and there's lots of reasons for it. So the performance gap is saying it's designed to be low energy, but it seems not to be low energy in use. And lots of those reasons are not necessarily to do. The design doesn't necessarily get translated into what the consultant design then gets picked up by installers and amended to make sure that it works within what installers can actually do. So like, the consultant may have put something out, an outline, and then it may be picked up and then it is effectively redesigned, but maybe not to the same assumptions the consultant was working to, but they're to what works now, especially under that often is done by design and build. So under cost pressures from the contractor saying, how do I make this more cost effective? So how do I make sure that, this works and I can make some money on this job? And then often, projects take longer than expected. So a client will want to take on the building as soon as possible. So they don't get commissioned. Often buildings don't get commissioned to run the way that they were designed. So, a good example is not heating, but lighting. Often lights used to be put on at full power when actually people design them with they design them to be controlled down to a suitable lighting level, but they're then running at 1,000 lux and not 300 because they're not commissioned down to the right level. And the reason you might over spec the lights is because historically over a life cycle, an LED gets dimmer. So you want to have that you want to over spec the light. So over the lifetime of it, you always get 300 lux. So all those things come together. If it's not commissioned properly and no one's checking whether it actually operates in accordance with the energy performance expected, you end up with this energy gap, this kind of performance gap. And, there used to be a misunderstanding as well, like the model that's used for building control compliance, the Part L models that are done, they're not designed to be reflective of the actual energy use. They are a model to say whether a building is more or less energy efficient in accordance with building regulations. So you need to do a much more sophisticated energy model to understand what the true energy cost is going to be. So I think there has been loads of learning around that, and it has improved. And I think the sports centre we did for Portsmouth is a really good example of where all that learning came together and delivered a building that actually is really low energy in operation. The main complaints about the building are that it's too busy because it's a really popular building. So yeah,
So there's some interesting things you mentioned there. So one of the things I want to come back to is this fabric first. I just want to talk about that in a minute and what you in the consultancy world or the consultant world is thinking about that. The other thing is the installers. So for the lay listener, when a consultant sort of gets involved for the client and sort of designs something, etc., who then chooses who implements and puts this stuff in? Who then chooses who then commissions it? Is it the consultants or is it the client?
No, so on a big project, so the consulting engineer, so I'm not a consulting MEP engineer, I'm a sustainability consultant, so I work at a slight level above that. I talk about the strategy rather than the actual design, but the consultants will design the mechanical and electrical systems, and there'll be a series of drawings, schematics. It'll be schematics showing, how the system's organized, and then some drawings showing how they're laid out, where the pipe runs are going to be, that kind of thing. And that level of detail is according to the level of design detail. And then that is then tendered to a main contractor, okay, who will deliver the whole project. And then they will take packages of work. So the electrical work they'll take to the electrical contractor, and the mechanical work they'll take to the mechanical and they'll have a mechanical and electrical subcontractor who will deliver that work, as a package of work for the main contractor. And the main contractor is they are the organizers, and building stuff's really difficult. So, their job is to coordinate so many different things in the real world, so many packages of work and so many different subcontractors. So ultimately, the consultants may continue to work. They may then work for the contractor rather than for the client to help deliver it. But more often than not, the subcontractors who deliver it, they may carry on the installation drawings and the design. What was really interesting about Ravelin is that Max Fordham we then went and worked for the M&E subcontractors and did the installation drawings. So that was like one project, which is quite rare. We took the design from literally what's the concept to somebody at Max Fordham drawing, where the pipes and wires actually went for whoever was going to install it on site. And they also did a lot of prefabrication of M&E services offsite. So lots of that stuff, all the pipe runs, you probably should speak to Ewan who worked on lots of this, but basically they brought those in as pre-built units, factory built units, and then assembled it on site.
Well, that sounds like quite a good strategy, doesn't it? To concept, stage a concept, and them sort of people working all the way through, because it can
Yeah,
sometimes, as you will know, be quite a disjointed affair, can't it? All this.
yeah, I think so, and I think it. There are reasons for it, and I think it's. We'll talk about this a lot, but basically, on that particular project, I think the incentives all aligned. Everyone wanted to do a really good job because it was the first BREEAM Outstanding Sports Centre. Um, like a lot of people, like it mattered to the university and to the contractor and to everybody from a kind of PR perspective because it was going to be a kind of project first. So perhaps the profit motive was less important than the PR, demonstrating that we could all do this really high quality job, and therefore everybody was kind of on board with, pushing it through. I mean, the project took quite a long time. It wasn't delivered on time in the end, but it was delivered. It is working really well, and also we had this thing called a soft landings champion appointment. So, and I did, well, I sort of led it all the way through. So my job was to make sure that during the design stages, the universities, that the design as being developed by the MEP engineers was regularly fed back to the facilities management and the operational staff and the university, and we talked about really boring things like light switches and how it was going to be cleaned, and we had workshops around what might consider to be like, maybe mundane from an architectural perspective, but really fundamental to whether the building was going to operate well with those people. And it was always giving a heads up to the reactive and planned maintenance teams about what they were taking on, what the systems looked like, what we proposed they needed. And I think it's funny because all the way through from me as a soft, I kept feeling like, I wish I had more engagement on this. I'm running these workshops, people aren't saying very much, but I'm constantly like banging on about it. And a lot of it was during COVID, so to do quite a lot of it online. I started off doing it in person, and then we were doing it online, and people would just sort of sit through quite long sessions where we were taking them through information. But ultimately, I think it worked. Well, it definitely worked. The projects worked really well, and some of my colleagues continued a 2-year appointment to do post-occupancy evaluation. So looking at how the building was operating in detail, and then going and talking to people regularly about what was and wasn't functioning as designed, and then we can constantly work on those things. So that was quite an effective, without that sort of thread throughout, it may not have had such a good outcome.
Yeah, no, I like this a lot. So obviously, as you know, I'm sort of involved in sort of learning and training. So it sounds very like familiar to me, but it sounds a little bit like constructivist learning theory, which is where you sort of a lot of training, especially in my industry, in all trades, or well, actually in all education, let's say, so someone will think, right, this is what people need to learn, uh, and then they'll write a course, write a curriculum, and then they'll give it to people. But the people that they're giving it to have had absolutely no say in what they wanted to learn.
Yeah.
Whereas constructivist learning theory is about having them as active participants in their own learning journey. And it sounds like you kind of had something. The people that are actually going to be using this building, down to people that are going to be having to clean the light fittings or etc., were involved in the process.
Yeah, I mean, I think, and like, even ideally, I was looking for like loads of feedback, but actually, what happened was they just were aware, always aware of that they were, of what was coming, and I think that was helpful. That was like, if anything, that was a really helpful thing for them to always be like given the opportunity to say something, speak up, highlight any issues, have them noted down, and have the design team consider how to address them.
Yeah, I like the sound of that.
That was kind of really helpful, and I think it meant that when the building when things weren't necessarily ideal or as designed, which happens in every project, they knew they knew they could sort of speak up and say, well, I thought this was going to be like this and it's like that, so can someone address that? Whereas I think often new buildings can be done to people rather than something that they are, you know yeah, rather than something that works for them or is.
Yeah, have them as involved as active participants, isn't it?
Yeah.
So yeah, like I say, before I forget, this thing about Fabric First. So you've seen some changes because obviously if we go back,
Yeah,
like,
I mean, I would say that our advice is really different to how it was. And I just think it's really interesting because it was like Fabric First was like, it was almost as though people felt that they were like, it was morally wrong to abandon that as a strategy. It was like, this was being for so many years, my sophisticated advice. And the ground has changed from underneath me. The grid is decarbonized. From a carbon perspective, there is much less reason for doing it. But I mean, there are reasons for improving fabric. There are really interesting ones. So, you know, buildings are effectively energy storage. Like if you can, new buildings should be as energy efficient as possible. Then we can, like, buildings can effectively be really good demand shifters in themselves. That shell can do that work. But if energy efficiency, if fabric improvement was easy, everyone would have done it. It's really hard.
yeah,
Like, if it was straightforward, if it was like, oh yeah, we should just insulate homes, if it was that easy, it would be done already. It's deeply disruptive. And I think lots of things can be easy to say, but are really hard to do. And I think fabric improvements are sometimes some of them. And like, you know, even the improvements, double glazing cannot be as helpful for windows as putting big thick curtains on it. And people are sort of think, oh well, I'll put double glazing on. And it's like, yeah, but there's a lot of other losses in other places. Like, normally doors and windows help because of they reduce infiltration losses. It's not the U value improvement that you're going to get from them. But I mean, there's lots of reasons for doing fabric improvement. Sometimes, uh, you know, you significantly reduce the size of your heat pump. You can obviously, like, if you can get it right, you can obviously keep the same radiators, have much lower losses. But it has to be all balanced in the round. Like, I think this is one of the biggest obstacles is that lots of people have their kind of particular religion around what their thing is that will be the silver bullet for the energy transition. And I think it really is, like, basically being very uh like, yeah, basically not picking a winner, looking at what is the solution for each project. You've got to be pretty, yeah, you know, open-minded to what the right solution might be,
yeah. I think
in a opportunity.
you hit on something very interesting there. You said it can be difficult, and you're right. There are so many people because obviously in our minds it makes common sense, to improve fabric. Why wouldn't it? It makes common sense, but there's so many people constantly saying it, and you just know. And I'm not being dismissive, but you just know they've never been involved in buildings whatsoever because there's this whole mantra like, fabric first, has to be fabric first, and you just feel like saying to some people, have you actually tried to do any of this stuff? And do you actually know what you're talking about? And you're just disseminating a sound bite. It makes you, and I'm not just, once again, I'm not dismissing these people, and I'm not dismissing it as an implement as a measure you should implement. But yeah, it can be extremely difficult in certain instances, and sometimes it's not as much as needed as just other different strategies. Because let's talk air to air because you've got your F gas, you've done air to air.
Yeah,
You and I know you can go out and buy a 4 kilowatt air to air mini split system at 600 quid. You can heat. If you've got a small little property, you can heat your little downstairs with that. No outlay. You've got
yeah,
cheap electricity now, and you haven't had to do anything really apart from bolt that on outside and bolt a internal fan coil. Yeah,
yeah. I mean, like, a single split unit is like half a day's work. I mean, I'm not an expert installer. I've done my F gas and I've done my City and Guilds RAC course, and I've had hands on, and I did it because my project could do with some air to air, and we'll talk about this in a bit. I have done an air to air system which I used. I work with you know, I work with an experienced installer to do that job, but I do think that yeah, you've got to pick the right solution for the job. So the downside of air to air is, like, from a sustainability perspective, is that there's quite a lot of refrigerant, and those refrigerants are pretty high in global warming potential. And I don't think it's going to be a solution that will last. It's a great solution now for the next 15 years, perhaps, for the lifetime of one system. But ultimately, we're probably going to come up with, it's the fan coils that are amazing in air to air. because ultimately people who don't want lots of radiators, you can get a lot of heat output from
Mm.
uh, a lot of heat output from quite a small unit, and it just gives you loads of other opportunities, and it is pretty cost effective. Like, I'm sure lots of flats will do well with an air-to-air system, or like a multi-split, maybe two heaters in a space. But yeah,
I mean, the refrigerant thing is right. I mean, this whole thing of sustainability. I mean, one of the problems is with the training. I mean, I don't know too much about the F-gas training industry at the moment, but obviously, if you do things wrong, you're going to get leaks. But yeah, you should have leaks. I mean, we decommissioned a system that we put in 1986. It still had the same weight
yeah.
of in it. I mean, you do things properly. You're not
I
going to.
think it's frustration for me because I can go to lots of stuff, but my colleagues do lots of my team does a lot of embodied carbon modeling, and refrigerant is one of those things. And there is this assumption that a VRF system has a 6% system leakage per year. Now that's based on the fact that one in 20 systems fails catastrophically, but in a year. And I just think that the often we kind of load. I don't know where that number comes from, and my experience of standards is that it may not have some really strong, I don't know, it may or may not have some strong evidence base behind it. But, a monoblock is like 1%, it's a 1% refrigerant leakage rate. And these are numbers that are used to say what's the life cycle embodied carbon impact of that element. And I mean, they're there because there's some, but I think perhaps they are, if you, the quality of installation really matters.
Yes.
Some companies will have no leakages ever, or like it'll be one in 200, which is to do with like the unit failure or something. It's probably much higher, and some organizations which have perhaps less thorough processes or less high quality work may have a higher leakage rate, but I don't think it probably is as high as the kind of assumptions we have to use for that modeling, and therefore that is a bit of a barrier sometimes to getting some forms of heat pumps into buildings.
But you're right. It's a strange thing with refrigerant because it's literally everywhere on the planet. I mean, as people are starting to become aware, because I try and make them aware. This stuff. There's probably they estimate 5 billion compressors on this planet. I mean, your Costa coffee machine's got a heat pump system.
Yeah,
That all that metal shelving in shops and heat pump system. The vending machines. How many vending machines must be on this planet? I mean, you can go to was it Switch? Is it Switch? You get vending machines selling cheese here, there, and everywhere. Vending machines everywhere, all heat pump, using refrigerant. But I mean, so things like the Peltier effect and this thermoelectric, what I would call a solid state heat pump technology. That technology's been around quite a while, and people are starting to sort of really innovate with that. So I think that's quite interesting. So you're still going to get the efficiencies associated, the laws of thermodynamics associate with heat pumps. We can still get these really, really good efficiencies with that kind of
yeah.
stuff.
I mean, I think it's interesting about heat pumps is that, and we have this conversation with clients sometimes, is that they're like, because the grid is becoming really clean, the reasons you have a heat pump are not the carbon saving, because let's say in 2035 we have zero carbon heating system. They're actually about managing your energy peak for the building. It's basically significantly reducing the load because there's no carbon impact of that resistant heating, but there's a massive grid build out implication of it, and also cost, because electricity, heat pumps need to be really efficient at the moment because the spark gap, the cost difference between electricity and gas is so big, and electricity is so expensive. But you know, in a future of low cost electricity, let's say when it's abundant at times, they may not be so relevant. So I think I just think about what heat pumps are doing. They're making the energy transition for heating work right now, and I think going forward they're still going to be the technology because they are so efficient. But yeah, I mean, they less and less it's about the carbon saving, because direct electric delivers quite a big carbon saving nowadays. It
Yeah.
just doesn't. It just costs a huge amount, both in grid build out and in terms of your electricity bill.
Well, this is why the solid state heat pumps are interesting because they use no refrigerant, no moving parts. They hold a lot of interest for me. Now we're going to talk a little bit because you've said why you've done this. You work hard enough as it is. You've got a young family, but you set up a company that's an MC. You've gone out and got
Yeah,
disaccredited. Well, so I'm going to chat about that in a minute. I just want to quickly, while it's in my head, remember, because when I introduced you, you've done two masters. One of your masters is in environmental psychology.
yeah.
And I remember I did a module in environmental psychology. It quite interested me. I mean, I think I learned some really curious things like men, like they don't, as long as they got high ceilings, they can be in kind of tight places. Whereas women they like spacious sort of. So that's what why they reckon churches ended up with. You could be crammed into church, but as long as it had a high
Right, yeah.
ceiling, no one was sort of breaking out fighting or something. I don't know.
Yeah,
Well,
it's a really interesting field, and the reason I did it was because I was I was still rowing full time, and I found rowing full time boring, and I'd done my MPhil in environmental design, and I'd done my part two in architecture, and I all the way through my environmental design stuff, which is a research degree. They'd always come up. They'd be like, "Oh yeah, well we can design low energy buildings, but actually, what matters is what people do in them." And I was like, well, what is it you think that people do? And it's just really interesting because it's like kind of conception of there's two sides to environmental psychology. And the bit that I got into actually in the end is what you're talking about. So basically like how space affects the way we do things and what we do, and understanding like why, the interaction between the physical world and decisions that people make. So people environment studies. There's also a whole other discipline which is also very interesting on like sustainable consumption and how understanding how do you get people to act in a more pro-environmental way. How do you think about what does the kind of psychology of littering, the psychology of like understanding why people like how people use heat in buildings, like ideas around the thermostat, all that stuff. That's actually this kind of like niche that is also explored. And I was quite interested in when I sort of thought I'd do the course. I was interested in that side of things, and actually, the work that I've done at Max Fordham since I've done quite a lot of work in designing for well-being, understanding the things that have an impact in design, in architecture, the things that really have an impact on people's quality of life. So that's the stuff that I have been doing. I do that as some of the work I do at Max Fordham in terms of master planning, in terms of like thinking about office design, those elements. Um,
what's the top
uh,
tip? What's the top tip then? What sort of springs to mind if for people's well-being? What is sort of one of the
well,
number
I
one
think okay.
things?
So basically, the thing is, all these things that matter to us, they're not things you should maximize. So,
Right.
so think about everything's about imbalance. So, like too much light, everyone's like, oh, I want loads of daylight. That's called glare. Or too much. I want loads of ventilation. That's a draft. Do you know what I mean? Like too much of a good thing there is always too much of a good thing. Yeah. So like you want to have these things in balance. Like there is a right amount of daylight that you're trying to look for, and you've got to balance those needs. And you know, certainly in terms of workspace design, we have like different privacy needs and they all need to be met. So I did actually my work at the end, the work I did was actually looking at academic workspace because academics need somewhere to really sit and think. Like, and a lot of office work does not require high cognitive loads, let's say, like it's not actually, and you may want to natter with your workmate, but like someone who's thinking about like the origins of the universe or solving mathematical like theorems, they need like a very quiet space to work. And trying to get people to think about those different privacy needs. You also shared offices can be really hard places for people to work to because it's quite difficult to tell the other person to shut up. And like that interaction, how do you manage that? How do you think as a designer about how those space needs are met? That's the kind of thing that is interesting. I mean, and also that access to nature is really important. You get effectively, there's lots of work that's quite interesting around what's called a sort of nature dose. So kind of the richness of biodiversity and the time you spend in it has an impact in terms of it's called attention restoration. So if you spend a lot of time in nature, you'll often find yourself like, oh, I feel recharged. And it's quite difficult to describe, but it's clearly there as a phenomenon. And understanding that and understanding like trying to understand what brings that about. Is it kind of the fractal nature of plants? Is it what is that element? That's quite interesting to People can't seem to do research without trying to pick apart why and isolate it. But ultimately, those things like basically planting, access to outside, access to biodiversity can have a really beneficial effect in terms of workplace design. And I think we've known that, and I think that work. You see offices with lots of plants to try and sort of address that.
Yeah, I've been in some buildings and they've got like what they call living walls, and
Living walls,
they're
yeah.
different sort of mosques.
But the thing is about how you do it is like, where do you want it? Do you want it in a space? You probably want it just near around your workspace. You probably don't want it in like somewhere you're going to spend, you're going to take 5 minutes to walk to and are rarely in. Put it in a central atrium with
That's
nowhere to sit. It's not really
yeah.
going to do the job that you need it to do.
Well, the one I'm thinking of, it's a very famous. I'm not going to mention it because I'll probably get told off to mention it. But it's a very famous building, and it's in the foyer, where people walk in. So
Yeah, yeah, I know.
visitors see it and probably think, "Oh, this is really nice." But yeah, the poor old people
Yeah. Well,
working in that building aren't really accessing its benefits, I suppose.
yeah, yeah. Well, that's another thing. That's something that I think is really interesting. Is that the reason they put it there is it's like a status raising thing. It's about how they're communicating to other people about how great their workplace is, and not necessarily about. And I think that's one of the things that's really interesting in terms of thinking about heating systems and the heat transition. Is you hear people say stuff like, "Oh, someone's going to spend 20 grand in the kitchen, but they won't spend 20 grand on their on their heating system." And that keeps them warm and that actually makes their life nice. And like, I completely agree, but also it's kind of this hidden force that status, like a lot of people don't like. It's sort of quite difficult to talk about, and it's very embarrassing. But like basically, heat pumps or when having a gas flue sticking out your side of your house is a kind of low status thing. That's when heat pumps are going to take off. You know, and obviously and it happens in every space. EVs to some extent have that within certain groups. So often status seeking is within your group, within your community. People are into climate change and the environment. They're looking for a heat pump now because actually that is a status raising behavior amongst the people that they value. But it's not for the general population. It's like I just want to have a house that's warm.
That's
So I think those kind of forces are really important in terms of understanding what how we drive the sort of domestic side of the energy transition.
very interesting stuff. That yeah, I like that. I like that a lot. I mean, that comes back down to sort of behavioural psychology, doesn't it? And this whole thing of the status. I mean, it's working at the moment with innovators well, not even probably at the early adopter stage, but for mass adoption. I mean, it's no probably different to when people start to mass adopt central heating in their homes because that was a very sort of I don't know if you'd say it was a slow transition, but it was a transition that took a few decades. So, like, even though my grandfather was like this, flying all around the world doing all this stuff, my dad was a heating engineer. We didn't get our heating system installed into our home till 1981. So I lived out in the country in rural Norfolk, and we didn't have full central heat. People had their individual heaters. We had coal fires, and people had paraffin heaters when I was in the 70s when I was real young. But yeah, so over time people were getting full central heating, and I'm trying to think quickly whether someone like my dad would have got it to be part of the state. I don't think so. But, yeah, that's a really really interesting thing.
Yeah, I think about it, like I remember my granny died in the early 90s, and she had a house. She lived in the countryside with storage heaters. Storage heaters in a Rayburn, and like the estate agent came around and, well, this is unlettable without central heating. You need to put central heating in. Because like my dad was in the army, moved around, so the house needed to get. My dad wanted to rent the house out, and they were like, well, you can't do it with that old system, and like that's an example. That's where it's coming from. It's like it was like having non-central heating in that house was like not having a decent kitchen would be now in terms of its kind of lettability and desirability. And I think the time will come when you won't be able to use the time of use tariff because you're on gas, or like, do you see what I mean? It's like those things are the things that are gonna drive it. It's like, oh, what you mean? I'm gonna, what I've got to use like the older, I can't get these other benefits because
Yeah.
I've got an old gas boiler, right? Well, probably should get on and get that heat pump sorted. And I think that's when we get mass adoption, and we're a long way from it now. And it's probably the listeners to this podcast who are the ones who are, for whom having a heat pump is part of, like, uh, you
So,
know,
so talk about MCS. So you made the decision. I think you've partnered up with someone. You wanted to become a
yeah. So,
installation company, and so you've done some training as well prior to that, obviously, because that's part of the process of them becoming them. So talk us through that. How's that been for you?
well, it's been interesting because basically I have this. My house is a grade 2 star listed house in Margate. It's pretty. It's pretty much the oldest house in Margate. Um, and it is like, it was medieval, and it was turned into a sort of, it was turned, like, the house I live in was turned into like a farmhouse from like a medieval hall in like the 17th century. Like, it's old. Anyway, and like a lot of it, like the windows are the windows that were put in to make it a Georgian farmhouse. That, and there is nothing I'm allowed to do to them because they're Yorkshire sashes. They're rare. They don't. So, it's not. You wouldn't look at it and think it's quite a straightforward house. Now, I kind of would like to have a heat pump. I'm quite into this, and if I'm honest, I sort of had, uh, I sort of got on the journey when I didn't know as much as I do now. I mean, I've always been able to do heat loss calcs because I have an MPhil in environmental design, but like, in terms of like understanding the heating, like really the nuts and bolts of heating is actually fairly recent in my life, in the last 4 or 5 years. And anyway, so I got a local installer around, and just basically everything they told me, he's not MCS registered, but you could do heat pumps. Everything he told me was like not what I had learned from your podcast, other sources of information, Heat Geek, all of that. And I was just sort of like, well, basically, I mean, yeah, yeah, I need to put like, it's like probably 24 kilowatts heat pump minimum. Oh, I put more on it. The MCS calcs under measure it, etc., etc., etc. Just like everything. And I was just like, you know what? I'm just gonna. I had been working with a heating engineer who's like a mate of mate, who I sort of got introduced to when I first moved down here. And he was like, he's Polish, and he was like, yeah, quite like to get into heat pumps. And we just had this conversation, and it was like, well, okay, well, you can do my heat pump, and we'll figure this out. And then it kind of came, this conversation. I did, when the Heat Geek Mastery course was sort of on the biz funding,
Oh
as
yeah.
it was. I did it then, along with a few other colleagues who were like, we were interested in, one of the requirements is you're going to get into the installation of heat pumps. And we were like, okay, well, we're going to do this. And it was really interesting to do that, and to then kind of get involved in doing the hydronic design for my own house, because effectively our house was a conversion of, it was actually had been split into two flats, so we were reconverting it and reconnecting to heating systems, which actually makes it quite easy on some level, because you're splitting down demand already. So you have double the pipe work. So you just have a large primary joining the systems, but effectively, you've got reasonably sized pipe work to those radiators for the level of, each of those runs has, is reasonably sized. And I just realized that it was going to be much more overall, it would work better for me if I did it and owned the whole process. And then basically Conrad wanted to get into heat pumps. So I was like, right, well, work together and I'll help you with the MCS. We'll go through the whole MCS process together. So it's entity. So I've got to thank Max Fordham for being, I've never been that explicit about what I was doing, but like, they're just pretty tolerant of me, like, going off and learning this stuff. But it has been as difficult, I think, as a heat pump could be, because my grounds were a scheduled monument. You're not allowed to dig any more than 30 centimeters without consent from the Department of Culture, Media and Sport. Like, basically, I need to have scheduled monument consent to have a heat pump in my back garden, because it's in the scheduled monument. I also needed planning permission and listed building consent to have the heat pump. And actually, it turned out that's the most contentious thing I've asked for in the entire renovation of my wedding venue, which involved a lot of new walls, a lot of moving things around. And the thing which made my planning officer most excited and send the heritage officer down was a heat pump. And that, luckily, there was a great heritage officer in my local authority, and she sort of, apparently had, like, had a great chat with the planning officer, saying, no, this is a technology that all these houses need to have. um, you know, you should probably support. I'm supportive of it. We should be supportive of it. But yeah, it's taken forever. And then obviously I want to install it. I got a NAPIT. I joined NAPIT, got it audited. And like the most recent thing is that I still haven't actually received my grant because it's gone, apparently been randomly assigned for a bus audit. But I've had a site visit. They wanted to check that it really was a heat pump. And it may be that my business is registered to my house and they were wanted to check that, I really had put a heat pump in. But yeah, it's probably the most audited heat pump system, certainly in my end of East Kent. Yeah, I'm waiting to get my bus grant for it because I put it in November, so I'm running towards the 120-day limit from the moment you apply for it, from the moment you install it to like claiming.
So you're happy with it? But you've had it running.
Yeah, I mean, so basically what I did is I really wanted to try out I wanted to try out the time of use controllers. I want to try out a homely controller. But actually what I ended up doing, because I like that kind of thing, is I've installed it it's a Samsung. So and I've installed it with Samsung controls. And I'm going to basically run it for this winter with Samsung controls and compare it to next year. It's interesting. Its performance dips quite a lot. The maximum flow temperature, it's on Open Energy Monitor. It's kind of up there. If you look for Margate, you'll probably find it under thermal delight limited. But basically, it's like, the maximum flow temperature is 41 degrees when it's -3. So it's like, it's size. We've got cast iron radiators everywhere, so it's got this massive system volume. It's like 500 liters which is huge for a house. And it's kind of like it's pretty good until it gets to 3 degrees, and then it starts to get, you do end up with COPs of less than 3. But like when I first installed it, I probably had like, I don't know, 4 or 5 days of it being like 8 degrees, and I was like, right, I'm going to take on David Blakemore here, like 5.6, and then like obviously you get the tail off. I think the controls on Samsungs could be better, but it's just really interesting to see what that's like, because that's a lower cost heat pump. Conrad's done it. We've done another one for someone else, a Valent Aerotherm 5 kilowatt system. That's they perform much better in colder temperatures, I'd say, in comparison.
Well, they do. I mean, you've mentioned your 41-degree flow at -3, and then you mentioned how you were getting slightly. And just from a listener, because you mentioned then the sort of the temperature around where we've got lots of humidity in the air, and that's
yeah.
Defrost. As you get below 0,
it could improve again.
It improves again. Now, what some people that have installed Valents have found is the Valent. Every manufacturer publishes information about what your power output is at different temperatures, and Valent. I've got to be careful that I don't get myself into trouble.
What, the 7 kilowatt may not be 7 kilowatt peak continuously.
Yeah, so they don't account for drop-offs during that sort of that little window when there's lots of humidity in the outside air. Now, I just want to help people understand. So you've mentioned a couple of things there. You've got a house that was built in the 1600s.
Yeah.
And you're heating it, or you're able to heat it when it's -3 outside with 41 degrees. Because there's lots of people still in this world that think you can't heat old houses, and if you did heat old houses with heat pumps, you'd need radiators the size of your whole wall. and I've met very, very, very supposedly intelligent people that actually do believe that. They think you need a radiator the size of a king size double bed or something everywhere.
Yeah.
And this is the trouble. People just don't understand the difference between temperature and heat. They're distinct things. They've got a great relationship, but they are distinct things. And people have got to get over this thing that you need hot temperature in your radiators. You never have. I mean, yes, let's say where it's -3 outside, and you had single panel rads in a house that was built in 1960. Yes, you might need your 75 degrees, but as soon as you've got the 9 degrees outside, you can go well under 55.
Yeah. But it's interesting. So if I sort of go back to Max Fordham work, just sort of the divert, is that we did a project with CO2 heat pumps, which actually are much more efficient when you get like a low return water temperature, and they can run, that scheme that we did is at 60, 70 degrees, because it is like a 60s listed brutalist building. So big concrete building. We made some fabric improvements, but we couldn't do very many, and it had to continue to be operated. So basically, they didn't replace these kind of smaller radiators and put CO2 heat pumps in, and like they, it sort of rattles, like, generally cops above 3, and which for a large commercial building is actually pretty good. So I think that's one of the things people don't understand, is that domestic heat pumps are so much better than commercial ones at the moment. The controls are just, you know, commercial ones haven't caught up yet. But yeah, I think you can get some decent efficiency at the high temperature with the right system. But yeah, I think my house, it has got some insulation, and it's just loft insulation. That's all I could put in. That's all I'm allowed to put in. Draft exclusion measures and loft insulation is basically what you can do in a big old listed house. And yeah, I mean, like my peak, my heat pumps peak load at -3 is 14 kilowatts, and it's pretty, I calculated it to be about 13. So yeah, a single heat pump doing a 4-bedroom house.
Yeah. I've got people, Henry, that tell me, "Oh no, that would need 50 kilowatts." Uh,
Yeah,
get training. So to get your MCS, one of you would have had to go on one of the tracks, so either
yeah. So
LTL awards.
interestingly, we both did, because I did my F-gas. I'm a member of RefCom. So Visa had an installer course, and we didn't realize at the time that it was just installer and not doesn't cover design. So we did that course. Both of us went on that because we were interested. So we, did the training. I have my water regs. That's because that's a requirement. So I've done water regs, but I just went on as a kind of like, I was really interested in what the course was like. And I mean, I didn't really learn anything on the day, I'd say. Uh, it was not, it was a 2 day, I think it was meant to be a 2 day course. You don't want to throw people under the bus, but like it was meant to be a 2 day course, and it was basically 4 hours in the end.
Is this
Where
the
it was like,
beta
yeah,
one?
this is the buffer, this is the heat pump. I mean, it's just like, I can't see how that was. To be fair to the trainer, the one thing he did say was, this is the only technology coming, forget about hydrogen. Like in future, heat pumps are going to be the heating system that everyone's going to have. So it's good you've come here. But that's about the only positive thing he said about heat pumps on the entire course. He said, well, if it's an EPC, if the house isn't an EPC B or above, just don't install it, walk away. Do you know what I mean? It was almost like a kind of radicalization against heat pumps for heating engineers, because I think, trying to get connection with the group and say, like, and also like not go beyond his realm of competence, but he probably has never installed a heat pump. I think he did say that, he's like, well, and it was just, and I think it was like, I could have thought that was a one-off, but then Conrad went on the BPEC and
So
had a
that was
very
just to clarify. So what the one you're talking about was Visa, and then
visa, yeah, which I don't think it run anymore. So
and then
Worcester Bosch sponsored that one.
was it face to face?
Yeah, yeah, yeah.
I
So
think
there's an online course, and then you do an online, you got an online, you do an online course to qualify, and then you go and do the day.
I believe they got funding for that course.
Yeah, no, I think, yeah, it's definitely funded.
Hmm.
I mean, I think the problem is that there's like the thing is that the incentives for training centers are that you're gonna the incentive for a training center, in order to get people to come, if you get a hard course, yeah, a hard course, if it's mandatory training, like you can't do something without having got the ticket, yeah, you as an installer are not going to pick the hard course. You're going to go and pick the easiest version that gets you the ticket. So for this training center, they're incentivized to get you through it. They'll get paid if you get through it, especially if it's funded. So it doesn't then become a useful exercise. They're not at all interested in whether you're competent to do the thing at the end, because like there's no incentive in it for you to be competent. Everybody's incentive is for you to get the ticket. So I think that's a problem, and I think that is, I think, well, I initially spoke to you about this. Like, I do think that's why I got in contact with you in the first place. Is there's definitely space for heat pump installation company to be very training orientated, and to have a kind of company built around the reputation and the quality of their installers. And I think that it is possible to train people to do heating installation, from scratch in about 6 months to a high level, if it's done in a really intensive way and you're learning from very skilled people. And I don't think that exists in the same way. There isn't funding for that kind of scheme in
No,
the UK.
the funding is going to traditional paradigm. I mean, it upsets me a little bit. So when I sort of first come on social media, when I first started my podcast, etc., at Beta, I talked to a lot free. I used to chat to them a lot. I knew the people that was, and what they were tending to do. They were looking at the industry, analysing the industry, looking at training. How does the train? Because they weren't involved in training back then. And that they, I'd argue, learned a lot from me because I'm probably the biggest voice that says the training paradigm currently does not work. And all of a sudden, I think what happened with Beta, they realised, oh, there's some money involved in this training. Let's get involved in it ourselves, and that's what they did. I think it was during COVID times. So obviously, people are going online more. Distance learning, e-learning platforms are springing up everywhere, and yeah, so they're interesting. Yeah, no, you're right. There's definitely. I mean, don't get me wrong. The government are very interested in this whole thing of the paradigm shift, and Nesta are as well. Engineers or people that want to transition, let's say gas engineers that want to transition, going out with companies, spending lots of time with companies, learning sort of the intricate stuff, that the tacit knowledge that being exchanged, rather than just sitting in a class for 3 days with someone at the front, who's probably a nice person, but has only just literally done the heat pump course themselves and is now allowed to teach it. Just basically going through PowerPoints with people.
Yeah.
And like you say, you're obviously, Henry, a very, and like the two principles of Beta Teach are activate people as autonomous learners and activate people as learning resources for one another. Now, what you find is you don't sometimes have to activate some people to become and take ownership of their own learning. Some people are naturally like that. I'd say you are. You really like learning stuff. And so when you go on a course, you're passionate about really learning. But like you said, unfortunately in this industry, a lot of people will go on the course just to get the ticket, and they're actually, if they know a place is going to give them their ticket easy, they haven't got to put a lot of effort in, it's going to be given to, that's where they go. That's an
Yeah.
endemic problem in this.
But I mean, even if I was like told you go on this course and you might, I mean, okay, so I mean, the Heat Geek course is really good. Like what they've done is amazing. Kimbo's course. So my Conrad, who's the heating engineer that I work with, he went on Kimbo's course. Like, thought it was amazing. Like, it's interesting that the good courses are the ones that don't count towards, like they're not. I think APHC allow you to use Heat Geek Mastery as your design ticket, but which makes total sense, but NAPIT don't. They're like, oh, it's not a proper BPEC. Which is just like, yeah, but the one actually, tests you and it's difficult. And I think like without the engineers that are really sharing stuff, so like Urban Plummer and Damon Blakemore and Craig Brooks, there are some people out there who share so much knowledge that I don't think they know the impact that it has. It's like really helpful. There are people out there who are sharing really high quality knowledge, really helpful on the forums. There are a lot of people that it's probably like, I don't know, it's probably 20 or 30 engineers who are sharing most of the heat pump knowledge in the UK and are driving up standards in terms of sharing what they're doing. And you can see like, that sharing, what good looks like on a regular basis. And it's quite, I think it's quite stressful to put that information out there because you're always going to be people looking to pick at it.
Yeah.
And I think I found that, without those people sharing that stuff, I would have never had any way of looking at what good looks like in the industry and understanding, what should we do, what good practice looks like. So I think like they are really valuable, and that's an incredible industry resource, and I probably don't know whether they know that how valuable that is.
Well, it's good that you're telling them because no, I don't. I did a podcast with Damon, didn't I? This will go out after that one.
No, I think it's out, isn't it? I listened to it. Yeah.
And because they are incredibly valuable. And what really upsets me, you've got all these organisations, entities,
Yeah.
charities, whatever they are, catapults, whatever. They're not interacting with these people. These people are at the forefront of this transition. They don't get any funding. They've not got
Yeah, I
access
agree.
to innovate money and government money and all this. And we've got these bloated entities now that are accessing money left, right, and centre that can't be bothered. Now, don't get me wrong, it's hard to interact with these engineers. They don't want to do surveys. They don't want to get involved in
Well, they're
they,
too busy installing heat
they haven't
pumps.
got the bloody time. But
Yeah.
you've got the time. You've got the time to get off your seat and go out and spend a day with them. Because I don't mind that. All the
Yeah.
Nesta crew, I
Yeah.
could name 20 people at Nesta that have gone and shadowed engineers. But I could there's not many other entities that do that.
Yeah.
They'd rather write reports and print out their lovely, wonderful infographics and think they've done a bloody good job. And they are lovely people. I'm not dismissing them either, but get a grip of real life and what's happening in the real world. It's these young men and women, and like I say, the knowledge they're sharing is absolutely amazing, and it's where all that's it's really where it's happening. Um, and I, as you can see, I get very passionate about it. Well, that's my role to help them and sort of disseminate their voice and amplify their voice. Now, so we've talked a little bit about MCS, and well, let's talk about the MCS side of things. And obviously, lots of criticism goes towards MCS. How have you found it being an MCS company? I mean, you're quite astute, Henry. I suppose paperwork's not too hard to you.
Yeah, well, I think that's the deal, wasn't it? Is that I could do a bit of paperwork and Conrad could install some heat pumps,
Yeah,
and I'd think about what the design looked like, but like, work with him because Conrad's pretty knowledgeable too. But yeah, I mean, there is a lot of paperwork, but it's really interesting because I was talking at a conference last week about this. So in my world of sustainability consultancy, there's always this debate about certifications. So, there is green building certification. To build a building in central London, to build a building most places, it needs to be BREEAM excellent or BREEAM excellent, which means you've got to tick loads of boxes in the design process to show that it's great and you've got to meet a certain level. Now, all of those things, you can pick about half of them. You'd be like, they feel a bit pointless and they feel a bit box ticky. And like, if you're the entry level job in sustainability in the built environment is to be BREEAM assessor and to sort of help teams navigate those requirements and deal with queries. And they all don't quite fit the job. There's all the criteria sort of sometimes don't quite fit the job you're doing, and you're like, well, I'm doing a boarding house at a boarding school. Why do I have to have cycle? Why do I lose 3 credits because I haven't got cycle parking? No one's cycling a bike here. Do you know what I mean? And it's like I've got that on several projects, but that happens, and you completely understand why. And it's like, well, because they've got to have a broad system that fits and reward things that are good in terms of health and well-being of residents and low carbon transportation and encouraging people to cycle around. So you understand why those requirements are there. And I think I sort of went on this journey of these requirements are really awkward and annoying and this certification isn't great. Then doing projects where we've kind of advised the client not to do certification, have a sort of bespoke system, set their own rules for what good looks like, set their own targets, and we'll do it. And then you look at the outcomes of the projects, and then you find that actually like the projects which had to do this really painful certification process also ended up with kind of better outcomes as a result. Like, yeah, you had to do some stuff that was unnecessary and painful and really you was pointless, but the overall system impact has probably been better. Like without BREEAM being required for lots of buildings in the UK, we wouldn't have lower carbon cement mixes being very common in the London market. So that's a systematic impact, or loads more kind of more environmentally friendly, lower VOC emitting furniture and products exist because there was an incentive for manufacturers to produce it because you needed it for the BREEAM ticket. So you get these system impacts from a really painful system that when you're dealing with the individual project, it's a bit annoying. I mean, I had this whole conversation about a type B RCB. So Samsung don't require type B RCD for their heat pumps. Like it's just not written anywhere in the manufacturer's instructions. If you look everywhere for it, there just isn't the requirement. So my heat pump doesn't have one. However, Valent have a very specific RCD B, and I haven't been that one. This project hasn't been, but it ended up we've discovered that their specific requirements, which are it's not just an RCD B, it's an RCD B plus, which has particular range of protection that it provides. And the cheapest one you can get is £400, and we did a whole survey, and I spoke to people on forums about it, and everyone's like, well, I remember Paul Spence replied to me and said, oh yeah, they don't cost that much, and it's like, yeah, but it's a very specific kind of RCD. It's not just a B, which you cost about 100 and something quid. They're still expensive. It's something else. And if you put a normal B on, the earth leakage is quite high. And it's just like those things, like you do the right thing because the manufacturers require it, yeah. But when you have the MCS audit, they're just looking for stuff that like yeah, has he got an RCD? I think normally you meant to have a B. Has he got one? And it's like, well, in this particular case, you don't technically need one. That is not a manufacturer's requirement. So I think that's the sort of, you know, but I think the existence of the process might be beneficial. I just think that I kind of agree with you that some outcomes should be measured, maybe. Like MCS should have more outcome measured. Like maybe they should all be heat metered, open energy monitor, you know, so like there's a public learning from them. But then what metric do you choose? So the heat pump I've just done for 5 kilowatts, it's like that client, that customer, he's got loads of batteries, solar on his roof. He doesn't pay any more than 7.5 pence per kilowatt hour. But it does literally never pays more than 7.5 pence per kilowatt hour. So for me to say to him, you need to have a temperature, you need to upgrade all your radiators. You know, you've got to spend another thousands of pounds for Conrad to come in, upgrade all your radiators. Just makes absolutely no sense when he could run his heat pump at a cop of like, when it's really cold, like less than 3, but it's still costing him £20 a month or £22 a month or something in the coldest month. It's like, well, why would I, why would I? So it's like, what metric do you pick? Because if you had an outcome metric, you say, well, it has to be a SCOPA 3.6 is a requirement for those jobs. But in this particular case, this customer, it would be like a terrible outcome for him. So there has to be always, you've got to have somebody on the end of it who really understands the technical issues and can take, this is why science works, it's peer review. Yeah, someone, the peers of the scientists review it and say, yeah, okay, I see, like that, what the work you've done, like is publishable because it meets the sort of evidential requirements. You've done things in a way that can come to that outcome, and yeah, we think this is worthwhile. So ultimately, there still has to be this human element, and I think the idea that you can kind of, but you need more. I think you just need a more sophisticated. It would be helpful if you had like really informed people doing the MCS audits. My auditor was fine and great, and like did know quite a lot of this stuff. But you hear stories of people who are audited by, they don't feel that they feel they know more than their auditor, and they're
Your
being
audit
picked
would
up
have
on
been
things.
NAPIT, is that right?
Yeah. Because I was quite interested. I think that solar and heat pumps are like a natural, solar and heat pumps are like a natural. Solar heat pumps and batteries are like really naturally go together, and that NAPIT also do solar if and when Conrad wanted to get into that.
You can't have solar though, can you?
No, I can't. I've got a battery. I've got some batteries.
Yeah.
But yeah, no. I could probably have well, yeah, it's difficult. I could have solar technically somewhere else, but not in my house, in my garden. But there's loads of trees in my garden, so I actually can't have solar.
Well, I bet you got some lovely trees if your house was built in, that.
Well, to be honest, a lot of them are grown, and yeah, they're like there's loads of sycamores that have just grown up.
So now I think I mentioned this at the beginning. It's not as if you've got enough work on your plate as it is, but you're creating sort of a wedding venue. Have I got that?
Yeah, so like other half of my house, it was a wedding venue,
Oh,
and the
right.
plan is to reinstate it. So we ran a bed and breakfast years ago on a boat in London, and we were sort of like we thought we'd do something on a bigger scale before we did that before we had kids. So we like during COVID, and we thought living on a boat with a baby wasn't probably no. After we had the baby, we realised it wasn't a great idea. So we moved off and moved to this house. So we left London and moved out to Thanet.
Is your partner, if you don't mind me asking, into sustainability and this kind of thing, or involved in this industry, or completely something a different?
No, so she works for NHS England. She's a senior manager and sort of is an epidemiologist by background. But it's interesting. She likes a warm house. You know, she works from home quite a lot and needs a warm house. So like that's where her interest in heating comes from. And to be honest, the heat pump is great for the work from home crowd because obviously you're heating your house all day. I think that's one of the interesting things about people say, oh yeah, you need to get a SCOPA 3.6 and then it's cheaper than gas. It's like not if you are only whacking your heating on for like max, let's say 3.5 hours a day, which is what we used to do when we both didn't work in the house at all. You just make it comfortable for the hours you're moving around and then you turn it off again. And like that's a really huge heating saving, which is very difficult to recreate with an air to water system. An air to air system can respond like that. So I think I think that's one of the challenges is like everyone does their analysis, and the analysis, is often done in a spreadsheet, not in terms of real world costs. And people react quite well to real world costs.
Can you see the new build sector adopting, well, either air to air systems or like I was speaking to Ken's today. I mean, because obviously their system, this ambient loop system, which is ground and water type thing.
Yeah.
I mean, you can have systems that have got a source of ground or water, and then and yeah, but my cousin did one out in he pulled energy from Lake Guardia, and then the sink was an air, so it was water to air.
Right. Okay.
And so I'm just trying to think. Do you think? Because I think there's a little play because obviously new build developments. Some people in the last 5 years, some people have experienced really hot homes and have felt very, very uncomfortable.
Yeah, there's definitely an overheat. There definitely was, because
So
they've updated the overheating guidance around. As building regulations tightened, you end up with these weird interactions of building regulations. So I think it's Part K for stopping falls. So you end up with like windows that can't really be open, and misinterpreting, people treating the approved document like it's the law, which
yeah,
it's not. It's
yeah,
guidance, as you like to say. But it's always been really important for me to point that out. So you end up with this like a 10 centimeter window restrictor to stop people falling. The restrictor ends up being 10 centimeters, not the opening. So you end up with the modeling for overheating being done that you can open a window 10 centimeters, but actually you've got a really thick window. You've got a 10 centimeter restrictor. So you end up being able to open the window, let's say like a crack of 3 centimeters, and you get overheating in the summer because you've got a really well insulated house and you've got probably more glazing facing south than you probably should have. And I think, and also there's an issue in terms of certainly blocks of flats. You end up with hot water distribution from a district heating system at high temperatures doing hot water all the way through the summer. So you have boiling corridors. So yeah, I mean, those are some of the things that can occur. And I think there is certainly cooling is no longer the demon that it used to be.
yeah.
Certainly 10 years ago, we'd say like, oh, you definitely shouldn't do cooling. It's really bad for the environment. Whereas now it's like, well, certainly in a world where there's loads of solar around, like a bit of cooling might not be the worst idea, to take off, especially if you've got, if you've got an air to air system. But I think one of the things is obviously air to water systems can do the hot water in a really straightforward way too. And I
Yes.
think that can be the fact you've got a heat pump that can do both is a kind of win. The exhaust air heat pumps are a thing. You can have like a smaller heat pump, can't you, that does sort of effectively it's air to air and also does your hot water. But
Uh,
like
as a consultant, have you got involved in any of these sort of the heat network typey stuff?
so again, as a sustainability consultant, I work in a kind of,
Yeah.
sort of what's the strategy, what are the objectives, how we're trying to get there. But yeah, I mean, Max Fordham have always been opposed to to heat networks generally. I think that's, well, I don't want to speak for the practice in total, but we've always pointed out that moving around heat there's always losses when you move around high temperatures. And if you have two heat pumps, you might have two heat pumps with a SCOP of 5, but combined they end up with not a great performance in the end. Do you know what I mean? So if you're stepping up and then stepping up, you're still like, you actually, if you're doing that twice, you end up with an overall less great performance. And then, we certainly have worked on a project where the first phase was a kind of combined heat and power heat network. And then the second phase, we were like, look, it's just, you really want to be looking at each unit. Domestic air source heat pumps, air to water source heat pumps, they are really good pieces of kit. And actually, we've probably got some good examples. We did an Oxbridge College not that long ago, decarbonisation project, and I think it's 24. We had 24 heat pumps cascaded, and like the modulation on that, it's incredible.
Yeah.
You know what I mean? From like minimum output to maximum by using really, I think there are Samsungs actually, but like, the opportunity like that can be done. Like actually, lots of smaller heat pumps, better for noise. Yeah, so 14 kilowatt heat pumps. I think they're actually, they're labeled a Samsung 16 kilowatt. Um, you know, so basically it's much better than 200 kilowatt heat pumps, much better controls. I mean, in the world of commercial heat pumps, Samsung domestic heat pumps have got good controls in comparison, you know. So it basically meant there was no acoustic enclosure needed. You know, one heat pump goes down, it's a tiny percentage of drop to output. Whereas if you've got 200 kilowatt heat pumps, it would be a bit of an issue to have one not working.
I mean, what about sort of the ambient loop? The sort of what people would call cold loops.
So I don't know if I've done whatever it's called, fifth generation or whatever. Yeah. So
Yeah.
I don't know what. I'm sure there's someone somewhere looking at that, but I honestly think that we should be moving around electrons. You know, electricity should be moved around rather than moving around heat. Like moving around heat is quite a cumbersome thing to do. That you can see the sort of ambient loop if you've got some cooling and some heating going on at the same time. So you've got commercial spaces and hot water. Like there's definitely a benefit to shifting heat from one place to another. You know, but I don't know whether I'm not. Yeah, I think that there's always going to be issues moving around heat in comparison to moving around electricity. But there's always, again, it's really important not to, you know, to be quite agnostic about what gets used, what
Well,
the
while I'm
technology
on
is.
the topic, I just want to say, because I did promise them I'd say, I mean, because I pushed back quite a bit against Ken's on my last episode. So, and I've pushed back against them on LinkedIn, and they did, bless them, because I said, look, and I've said this to a few entities now. I said, look, I don't want meetings, and I don't necessarily want keep it open on open platforms so people can learn, like a little bit like what you said with what the
Yeah,
engineers did. And they did write me a very extensive. It's actually a friend of mine from Kent, so Butcher. He's a lovely, lovely person, and they wrote me a really nice sort of. So well done, Kent. So thank you very much for that. And they explained some of the issues because I pointed out this the good work that Tristan has done and Glenn has done at Open Energy Monitors, showed that the Kenza shoe boxes were not performing very well at all in that electrification of heat project. And so, and I kind of people needed to know why. Yeah, why? So we can learn. And they've sort of mentioned that on well, I think they mentioned it on the public one. I'm trying to think if they mentioned it in the DMs now. But basically, that they use fixed flow temperatures. Now they don't have to use fixed flow temperatures.
right. Okay.
The interesting thing, and it is an interesting thing, and it's a behavioural piece again, because obviously they're going mainly into sort of social housing, and there is this thing about how do you educate the facilities managers in social housing, and how do you educate the occupants that your heating system is going to be not always, your rads aren't always going to be hot, because ideally, they said to me in this one, it was designed that they'd have a peak flow temp of 45, but it ended up being at 55. It's fixed. It's not sort of variable. And they did that because obviously the, the, the thinking is occupants are going to get a little bit worried about sometimes having radiators that don't feel that hot. Now, of course, that's a very, very good point, because that there is a problem with that, but it's an education and it's a behavioural piece, and we've really got to start thinking about these behavioural pieces. How do we get
Yeah.
the people in social housing to
I,
understand?
well, the thing is, okay. So this is really interesting. Is that I have always taken the perspective from a background from having done psychology, environmental psychology, is that like actually like uh, people really do understand some of these things. They've just got a different set of incentives. Do you know what I mean? They're coming from a different place, and like we can't change their minds by saying that oh well, it has to be done this way. It's like it's kind of where the benefit from heat as a service comes from. It's like ultimately, if we will deliver to you like an experience and it's going to cost you this much. I mean, it's like it's really hard to say to somebody for whom like, especially in a heat network, you have these sort of you're either paying some fixed service charge or you're being heat metered, and that heat can be really expensive. That's one of the big problems with heat networks, and you're kind of fixed into this, you're tied into this really expensive heating cost. Um, you know, if you can make it better, if you make it better for people, by sort of thinking, by basically giving them an offer that works for them, then they're much more open to, and it's to going with what they've been given. If you're sort of saying to people in social housing, you're being metered at, like, I don't know, 10p per kilowatt hour or 15p per kilowatt hour of heat or something, and it's going to cost you, like, it's going to be costing you £100 a week, you're going to find behaviors to try and stop that. Whereas if they're like, right, well, this cost is, you receive this heating and this is how much it's going to cost, and like, if you've got, if you want a smaller budget, we'll deliver less heat in a certain way. Like, if there's a much more kind of two ways, then they'll be more open, maybe more open to understand, to working with you. But saying they must learn how to use this system the way it is, because I mean, we so early on in my career, we did the biggest Agar Grove, which was at the time the biggest passive house development in Europe. Camden Council with a client, and they were basically doing it, like, a big reason for doing passive house was about eliminating fuel poverty. Effectively, it's like, right, well, we're going to minimize your heating through the design of these units. And there was all this worry, I think, about, the change in terms of, they weren't going to have heating, but they were going to have to, they had MVHR units, and they changed the filters every 6 months, and understanding that these MVHRs, which mechanical ventilation and heat recovery, they run the whole time, and effectively they use a little bit of electricity to take all the heat out of the air that's going out of the building and heating fresh air coming in. So you get good ventilation for very little energy cost. But people who are really worried about their energy bills might feel the need to turn off the MVHR, which is probably maybe costing them a couple of pounds a day maximum, but providing them with fresh air and heating. And it's sort of explaining to people that no, you shouldn't turn them off. But as designers and as contractors and as deliverers of that, you have to make sure that stuff that isn't noisy, and that those costs are completely bearable. And there's not an education piece. It's just a question of, people, they're like, oh, I don't understand why people are turning off the MVHR, and it's all because it's a buzzing fan, and they aren't, like, it's not a pleasant environment. That's why they're turning it off. So I think people generally do completely rational things, but you've got to understand where they are, to come up with this, a better solution for them.
So much of this is a behavioural challenge, isn't it? And understanding people. It's not just a technology thing, is it?
No, totally. And I think is a certain amount of listening to, like, what people's experiences are.
Before we covered lots of stuff, Henry, and I'm very grateful for that. And before we go, what is there? Lots of people talk about policy. So on social media, people are talking about policy. Everyone's talking about policy. Not so much engineers, the coal-face sort of heat pump engineers on there. But within your world of consultancy, are there certain policies that get discussed a lot, or would like to be seen, or?
I mean, yeah. I mean, I've got a particular one that I'd like to change. Like, I genuinely think so. The I think that we're moving into a world of, like, abundant electricity at some times, and, like, quite expensive, abundant cheap electricity sometimes, and quite expensive at others. And that is just the future. That's just what's going to happen. That's just what happens with renewables. We're going to have cheaper electricity, but it's just not going to be cheap. Sometimes it's going to be really expensive. So there's a kind of incentive about shifting demand and how you do that. And I don't think that's about people necessarily changing behaviors, but it's about battery. It's about lots of different technologies. But basically, that is all enabled by smart meters. Yeah. And the people and that creates a system benefit for everyone. If most people can shift their demand to outside those times, it means that on the high demand time, when, like, people with young families who need to do their cooking and washing, perhaps, that electricity will be cheaper for them. Actually, overall, the system costs for that will go down, because the peak will become a lot smaller, and there'll be less gas peakers fired up to cover that, less really expensive electricity being produced to cover that gap. So if most people who can shift their demand, who can do things a bit later, or have batteries can afford it, like, they do that, then we end up with society having even cheaper electricity. Yeah. And the grid build out can be less. So smart meters enable that, because you can have, like, accurate time of use tariffs. So I do think that, like, it's kind of mad that all the eco tariffs, all the taxes on the transition are on electricity, which is a cleaner fuel. So I would basically, my sort of wish would be that basically electricity that is, let's say, at least 60 or 70% renewable should be the tax should come off that. So basically, people who have smart meters should effectively have like it should be much cheaper off peak in order to shift people who can shift their demand to later periods. So I would like to see basically the taxes can stay on peak electricity effectively, but like there should be some formula to work out where we can shift that tax off the off-peak electricity, so that delta becomes bigger between on-peak and off-peak, and also incentivize people to move. I think a lot of people feel certainly there's a kind of smart meter infiltration that's kind of slowed, and I think some people feel like they don't really want to be like they don't see any benefit for their smart meter because actually the smart meter is a system benefit. Yeah, it makes the energy system work better, but for individuals, it just feels like a bit of surveillance. If there was actually a meaningful benefit to having a smart meter, so you got much cheaper electricity at quite a lot of the time, because I could see that'd be my like niche policy that I'd be looking for is basically no sort of additional eco tariffs on off peak low carbon electricity in order to kind of push people into middle class people like me getting some batteries because it helps, and that will then mean that people who have who need to use peak electricity can end up getting a much more reasonable deal.
Mm. And again, that kind of fits into the bit we were talking about just a minute ago about not so much educating people on sort of maybe why they should have a smart meter, but giving an actual benefit to make
Yeah,
them want to change to one.
I think when they first were rolled out, they were like, oh, you can see your energy use and you can reduce it. And actually, it's quite hard if you've got to like do your washing and have a shower and do all your things in your life to reduce your quantum of energy use. And that's one of the things people are like, oh, people should use less energy. It's really hard to do that. It's not that hard. It's less hard to shift your use. Running your dishwasher in the middle of the night on a timer, etc. Like those things, like it can be quite a quick habit to develop. Do you know what I mean? So it's like some shifting demand is much easier than reducing it. And
Do
so I
you
think
do
that,
you, do you do that? Do you run
yeah,
things
yeah, yeah, I do that.
like
I
at
mean,
night time?
to be honest, I've got batteries now, but
Right.
I do run my dishwasher at night just because I can. I don't run the tumble dryer at night because I think you've raised that, but basically there are some things that like ultimately I'm not doing as much washing in the household as my wife is. That's one task that is gendered in my house, and so she wants to do the washing when she wants to do it. We have batteries, so it's fine. But like I think that all those opportunities exist, and I do think that heat pumps plus batteries are going to have a massive impact in terms of reducing grid build out. And I think that's underestimated because they were really expensive batteries and they're getting cheaper. And I don't think they're like cheap yet, but I think they're going to become more and more affordable. And I think that'll be should be part of the heat pump offer. So it's not about turning your heat pump off. It's about using your battery to jump between, peak and off peak.
I remember when them adverts used to come out about smart meters, and it said, if you can monitor your electricity usage, you'll end up using less. And I said, well, you know, I can now monitor my bank statements. Now we've all got them done, and I actually spend more. I said,
Yeah, yeah.
long ago I had to go to the actual bank and say, "Cool, can I have a statement, or can you tell me what's in my bank account?" And but I can monitor it like within nanoseconds now, but it doesn't mean I'm
No,
spending.
agreed. Yeah. No, I think that's the thing. I think that's what's been misunderstood. It's like, oh, especially because things like leaving your light switches on don't really make much of a difference now because LEDs are so much more efficient. Like heat's where big energy use is, and there's not much you can do about, as we've discussed, it's hard to reduce your heating except through like better controls or a better system.
Cool controls. Well, yeah, you've got a Samsung in yours, haven't you? And
Yeah, yeah.
you're going to over the different years
I put a homely in
try, and
next
of
year.
course there's other different sorts of
And then
optimization.
yeah, there's also Haven Wise, which is like I'll probably
Well,
experiment with at some point.
Yeah, I like that. I really like the. Well, I really like the guys at Homely. I like the guys at Havenwise. There's another one sort of now, Cop Angel.
Right, yeah.
It's all that's a very interesting sector. That really is. Henry, been absolutely fantastic chatting to you. Thank you so much for coming on the podcast. Really appreciated it, and I'm sure my listeners have. And I'd like to thank you again for being one of my listeners, and I'd like to thank my listeners that are listening to this for being my listeners. Without you, it wouldn't be worthwhile. So thank you very much for coming on, Henry.
All right, cheers.